Problem 9. When a certain unfair die is rolled, an even number is 3 times likely to appear as an odd number. The die is rolled twice. What is the probability that the sum of the numbers rolled is even? So on the die, right, regardless of if it's fair or not, we always have the numbers 1, 2, 3, 4, 5, and 6. And since we do not know the probability of each number existing, let's assume that the odd numbers existing are x. Because if we roll an odd number, they have the same probability of existing. But then, an even number is 3 times as likely to appear. So this must be 3x, 3x, 3x. Now we know that the sum of probabilities always equal 1. So that means the sum of all this, which is 12x, must equal 1. Therefore, x is equal to 1 over 12. That means the probability of rolling an odd number is 1 over 12, and the probability of rolling an even number is 1 over 4. Right? Now with this establishment, we can basically solve the question from here on out. Because what is the probability of rolling two numbers that can be summed to an even number? Well, that must be an even plus an even, right? Or it must be an odd plus an odd. Now let's consider this as case 1 and case 2. Let's consider case 1 first. On the first roll, what is the probability of getting an even? Well, the probability of rolling a 2 is 1 over 4. And the probability of rolling a 4 is 1 over 4. The probability of rolling a 6 is 1 over 4 as well. So that means we can either roll a 2, or we can roll a 4, or we can roll a 6. And these are all the even numbers, so 3 over 4 will be your probability of rolling a even number on the first try, because every even number has a 1/4 probability of existing, and we have 3 total choices to choose from. So we have 2 or 4 or 6. Now using the same die, we roll it again, and if we roll it again, that means and relationships, and relationships and probability we multiply. And so we're using the same die here, so that means this is the exact same probability, which is 1 over 4 plus 1 over 4 plus 1 over 4, because we want all evens again. Now that will summarize case 1. Let's move on to case 2. Case 2 is the exact same thing, except for odd numbers. For every odd number, we have a 1 over 12 chance of existing. So for 3 is 1 over 12, for 1 is 1 over 12, and for 5 it's 1 over 12. That means that we can either roll a 1, we can either roll a 3, or we can roll a 5, or relationships we add. And on the second roll, we must also get a odd number. And so this has to be 1 over 12 plus 1 over 12 plus 1 over 12. Right, pretty straightforward. And so we have casework all completed. We always sum the cases. And so summing that would give us our final answer. Now you realize that for case 1, that is the same thing as 3 over 4 squared. And for case 2, that is the same thing as 1 over 4 squared. So that is the same thing as 3 squared plus 1 squared over 16. So that is the same thing as 9 plus 1, which is 10 over 16, simplified into 5 over 8. So simplified into 5 over 8, that should be our final answer. And nonetheless, lo and behold, that's answer choice E.